Even if we know where fish are and what they eat, fishing is still a great challenge. Fishing is probably one of the oldest forms of human subsistence, and it has great cultural, social, and economic benefits. Fishing with hooks is pervasive in recreational, subsistence, and commercial fisheries around the world. There's a lot of science that goes into catching fish with hooks. Anglers recognize this, and many keep logbooks or draw on patterns that they've experienced to decide where, when, or how to fish. I teamed up with researchers in the United States and Germany to synthesize the scientific literature related to catching fish with hooks. Our review paper was recently published in the journal Fish and Fisheries and is available to read online. Our framework for fish vulnerability was broken down into three components: the internal state of the fish, the encounter with the gear, and the selectivity of the gear. That's the yellow triangle in this figure. Just like humans, there's variation among individual fish in their shapes, sizes, and physiology that determine where they live, what they eat, and when they are hungry. Fish that are unwilling to feed are mostly not vulnerable to hooks, but internally vulnerable fish must encounter a hook that is the right shape or size to convince it to take in order to be captured. We found lots of really good examples of how fish vulnerability is likely to differ across contexts for many different species. This literature came not just from applied fisheries science, but also from research on fish behavior, foraging ecology, and ecophysiology. We divided the literature into key themes related to vulnerability, and we asked how the environment, social contexts, physical traits, life cycle, memory, metabolism, senses, feeding, movement, and fishing gear affect vulnerability. It's not surprising that each of these factors does play a role in vulnerability, and this means that fish that are captured by hooks are not a random sample of the population. Some fish are more vulnerable to capture than others, and it might depend on their body shape, gape size, or even their metabolism. A lot of literature on vulnerability really aligns with expectations. Fishers spend a lot of time in the water and have a great understanding of fish. It won't surprise many people that scientific literature suggests that fish are more vulnerable to natural bait than to plastic lures. However, evidence supporting different colors of lure, rattles in lures, or scented baits is less clear and seems to be species specific. Research is also ongoing into how the wind, moon phases, and pressure drops affect catches, and it may not be what you think. Anglers can shift vulnerability landscapes in their favor by understanding the mechanisms that make fish vulnerable. Fisheries managers can also shift vulnerability landscapes, for example, by restricting the hook sizes available to anglers. Beyond helping anglers catch more fish and increasing the efficiency of commercial fisheries, understanding individual variation that comprises vulnerability to hooks is crucial to many management and conservation initiatives around the world. This research will hopefully inspire more investigation into fish vulnerability and greater application of the concepts in fishing, science, and conservation. Thanks so much for watching. You can find this research and more from our lab at Carleton University in Ottawa, Canada at facebook.com/cook_FECPL. This paper and more of my research is at researchgate.net. You can also follow along with my fieldwork adventures on Twitter at FisheriesRobert and also on Instagram at FisheriesRobert.